Okay, Assalamualaikum warahmatullahi wabarakatuh. So we meet again. So this lesson is on the analysis of the magnetizing inductance current, okay, or ILM. Okay, so recall back that we have already derived the change of ILM during turn on, and we have also already derived the change of ILM during condition of off. So this is the two equation, and as usual, okay, for the inductor current analysis, okay, the waveform of the current as usual is we can actually write down, or we can sketch as okay, this is on, this is off, so it will, so this is a positive, meaning that your current will ramp from one a minimum value into a maximum value. So this one we call a mean current minimum. So this one called max current. So it will actually from, and then for the off state, so it will ramp down from max current to is a value of minimum current. Okay, so that is all about the analysis on the current inductor. So Imax, you can actually, so since you have a max and minimum, so definitely you will have some what you call the IL average. So Imax you can calculate by using IL average. Okay, IL average plus delta IL over 2, and I would like to mention again, so delta IL is actually this one, okay, between the difference between max and minimum, and also for I mean is actually IL average minus delta I over 2. So this one delta IL you can either use IL on, or sorry, delta IL on, or you can use delta IL M. See, so this is M during turn off. So you can use either. So please use only the magnitude only, not the sign. Okay, right now the problem is actually how is actually the IL average, how to actually derive the IL average. Okay, so the IL average can be derived from input power equation. So we have already know that P in is equal to P out. We assume that there is no power losses, and P in is actually a VDC multiplied with IS equal to V square over R. And we know that I source is only equal to the magnetizing inductance current only during state on. So we can relate this IS is equal to D IL M. Okay, so we substitute this into this, so we will have this equation as a VDC multiplied with DILM is equal to square of R, and okay, so since this is IS current is actually a constant, so meaning that this ILM is an average value. Okay, so this is average. So ILM average we can calculate by using V out over VDC. Or in other words, ILM average is you can just use D, okay, VDC over 1 minus D square VDC. So this one is you can cancel out, Okay, so meaning that you will have, okay, sorry, this is also got some D here, so this is also D, so you will cancel out this. So I have is actually a D VDC over 1 minus D square R. Okay, so this is your ILM average. So I write down the IL average here is equal to D VDC over 1 minus D R. Okay, I'm so sorry, there's some mistake here. There's some mistake here, so I will erase this one because I forgot to bring in the ratio. Okay, so we are correct until this one. Okay, and we should know that your V out is actually equal to D1 minus D, uh, then sorry, should be it should be N, sorry, the ratio N2 N1, okay, N2 N1 multiplied by D1 minus D V DC. So this is your V out. So actually this one you can write down IL average. This one it should be ILM. Okay, so you should understood. So this one should be V out square VDC, or you can expand this one. Okay, so it will become IL average equal to, so this one will become what is it, N to all will be uh, square. Okay, so I will actually over D VDC. Okay, so this one will be cancelled. This one also will be cancelled. So finally, my IL average will be N1, the ratio square, then D VDC over 1 minus D R. Okay. Okay, so next is about the CCM. So I will actually erase some of it. Okay, CCM. Okay, about CCM, so to ensure that your flyback in CCM, your I mean should be at least equal to 0. So, and then we know that I mean is actually I have average minus delta I have over 2. So this is your I mean, and we need to set equal to 0. And then we have already IN average. So this is your IN average here. And delta IN, you can either use IN on or IN off. Okay, it's up to you. So maybe I use the IN on. Okay, so I put here. So I give you N2 over N1 d VDC over 1 minus d square r, and this should be equal to uh, delta IN over 2. So which delta IN uh, I can replace it with this one. So VDC dt over 2. Okay. So finally, my LM, that if the minimum current value, I can write down as uh, you solve this, you can got the IMM minimum is actually around uh, 1 minus d half over 2f multiplied with n1 over n2 of 2. Okay, so that is your L minimum equation. Okay, so I think that's all for the current inductor analysis for the flyback.